Hello, everybody, and welcome to our video chat today. This is our fourth video conference with the Weddell Sea Expedition 2019, and some of you have been on our video conferences before, so welcome back. To those of you who it is your first time, welcome. My name is Lizzie Rosenberger, and I am the program manager at Reach the World with the Explorers Club for the Weddell Sea Expedition Education and Outreach. And we are able to bring these conferences to you with the help of the Flotilla Foundation. So normally we are live from Antarctica, but we had today a little something happen. I got a message from Holly this morning, and she told me that they were having a little bit of trouble with an ROV on board. And what that means is that the ROV is not working. So Holly and all of our guests we were going to have from Antarctica today, our AUV technicians, they have to all work all night, all day to try and fix the ROV. The reason that they have to fix it is because the ROV still has a lot of work to do. They're in the middle of the ocean and they are transiting, so they're moving from the Larsen Sea ice shelf all the way to where they think that Ernest Shackleton's ship, the Endurance, sank. And the ROV has a very important role to play in finding the Endurance. So I'm sorry that we can't bring you our technicians today.
That one writes though.
But we do have with us a very special guest named Buzz Scott, and he has got lots of experience in Antarctica. He spent 4 years down there, and he even spent the winters down there, which is pretty exciting. And he is also a ROV pilot, and I'm gonna let him explain to you what that means. But before we do that, I want to give all of you a chance to say hello to Buzz and Buzz to say hello to you. So we are going, when you have your class unmuted, you can give a wave and say hello nice and loudly. And we will start. I will unmute you. So we'll start with Miss Gary's class. Go ahead, Miss Gary's class. Excellent, thank you. Next, we'll head over to Miss Long's class. Welcome today.
Hello, guys.
Wonderful. And next, we'll head over to Miss Hogturp. I hope I pronounced that right. You can say hello.
Hi.
Hello there.
Wonderful. Next, we'll go over to Mr. Campbell's class. Let me unmute you. Oh, there we go.
Hello.
There's some familiar faces. Hi, guys.
Hi, Buzz.
All right, and next we're gonna head over to Miss Palmer.
Miss Palmer, that's a nice name.
Technical difficulties.
That's all right, it happens to all of us. All right, next is over to Mr. Bronson.
Hello, from Brookhaven
Hello,
National
Scott.
Lab.
How you doing?
Good, how are you, Buzz?
Doing well, thanks.
Wonderful, and then Mr. Thompson's class doesn't have any video, but maybe they have audio. Can you hear
Hello,
me?
everyone.
Excellent. We can hear you even though we can't see you.
I don't know. I'm working on the video.
All right, I'll see if I can help as well. And then we also I have one of my colleagues here with me, Chris Ahern, who is going to be doing the chat feature for us. So please make sure that you put all your questions, comments into the chat, and Chris will be monitoring that for us. And then we also have with us Julie Chase from the Explorers Club. So here's Julie to give us a wave.
Hello, everybody.
Hey, Julie.
Hi, good to see
You
you.
too.
All right, so I think that is all of our classrooms who are joining us today. We are so excited to have all of you. And without further ado, I'm going to hand this over to Buzz, and we are going to learn from him about ROVs and about what he has been doing in his work in Antarctica and the rest of the world. So Buzz, it is over to you.
Well, thanks, Lizzie. Hi, everybody. It's good to see you this morning. And I wish I was down there in Antarctica again, but unfortunately, I'm sitting here in New York. But it's a very familiar expedition to me. We have been down there. We've been exactly where they are in the Larsen B and Larsen C ice shelf areas. And as Lizzie said, I've spent 34 cruises down in the Antarctic and spent another 10 years flying ROVs. And one thing I know about Antarctica is you get down there and you're in charge of taking care of yourself. You're your own post office, your own fire department, your own police department. You take care of the ship, you take care of each other. And the ROVs are a finicky thing. They have between 15 and 20 computers on them. They have a long cable that's sometimes 3 miles long. And when that goes into the ocean, you're putting 4,000 volts of electricity into the ocean. So this piece of equipment is a very, very high-tech piece of equipment, and it's designed to withstand all of the salt water that it's put into, the cold temperatures that it's enduring, but it also needs a lot of maintenance. So what the guys are doing down there, I would assume, is they're doing a maintenance day, and a maintenance day can be a 24-hour day for the entire team. And they need electrical guys, they need mechanical guys, they need all kinds of people that really, really know what they're doing in order to keep this thing alive and running. And for the most part, these things run in the 90% or better percentile throughout their lives. And they're able to do some amazing things with them. So here we are, you're in all these different parts of the world, and they can go down 2-3 miles deep in the ocean, and they can send back video that shows you what's down there at the bottom of the ocean. Okay, now until about 1980, we weren't able to even get that far in the ocean with a robot. But now we have the ability to do it, and every year this technology becomes better and better. So, so what they're doing down there is they're working on a piece of machinery that is really quite amazing, and it does some things that you know, you might not even think about from day to day. So it has upwards of 10 to 20 cameras on it at any given time. It has flotation devices that keep it from sinking into the bottom of the ocean, because this thing weighs about 10,000 pounds. It's capable of driving itself down and driving itself back to the surface. It's neutrally buoyant. And what that means is when you put it in the water, it neither sinks nor floats. And then you drive it down to where you want it to be. And you have all kinds of instruments on board. You have a manipulator arm. Sometimes they have two. And with those arms, you can reach out and pick up a tiny little sea pen out of the ocean floor, or you can pick up a 250-pound rock. So they're very, very capable machines. And what they'll do is they'll go down to the bottom of the ocean after they've put the AUVs in the water. So the AUVs are going down and they're telling us what's on the bottom of the ocean. And then we use the ROV to go directly to the point where we want to go, where we think that shipwreck might be laying. And so they'll be probably doing, I would say, about 10 days of exploration. I'm guessing it might be more, it might be less. But if they can find Ernest Shackleton's ship, that will be amazing, because it's over 100 years now. If I'm right, 2014 will be 100 years. Is that right?
Yep.
And so to get down there and find a shipwreck that is 100 years old with this modern technology is pretty amazing. And for me, it's really exciting because, you know, back then they had no idea that this kind of technology would be coming along. And I bet if they knew that they had this kind of technology, they'd have done things a lot differently back then. I have worked on several ROVs in the past. In fact, the quasar, the SMD quasar that the Eclipse group has down there is a sister ROV to one of the ROVs that I fly for the Monterey Bay Aquarium Research Institute. And Lizzie, if you wouldn't mind,
yes,
we'll bring up a picture of that.
Absolutely. So I am going to go ahead and share my screen with all of you. And Buzz is going to talk us through some of the images that we have. So we just also had one class join. I want to make sure that they got on okay before we go to, it looks like they are all set. All right, so here we go.
There we go. So that is the Doc Ricketts. And you can see here that it has two manipulator arms. That one there that Lizzie's circling is the Titan. And it is, for lack of a better term, it's kind of a crane. And we're able to reach down and pick things up, and it can pick up a heavier load. So over to the, just to the left of that is the craft arm. The craft arm is more of a smart arm, and it has force feedback. So if I reach down and I pick up a rock, I can tell you almost how much it weighs. If I bump up against something with the arm, pardon me, the arm pushes back. And so I can use that arm almost as well as I can use my own arm. So they're very capable, and with all of the cameras, you can see on the front of this vehicle that there are cameras looking. That's the big film camera that we use for the BBC and for Discovery Channel, Nature Channel, Science channels, and they're very, very capable. They can zoom into the finest detail, and we can do a lot of great work with those cameras. Pardon me. And then up above that, we have the pilot cam and the science cam that they can also zoom and focus in on. And what we do is, you're looking at a flat screen, and so you're seeing 2D. With all of these cameras working together, we can look at the sediment and the samples and the fish and all the things that we're looking at. We can look at them almost in 3D, looking at the different monitors at the same time. So, it makes it very possible to, it makes it feel like you're right there on the sub. So above that, we have 4 lights. Pardon me, I'm trying to get this tickle going out of my throat. But we have 4 lights. Down in the deep ocean at 4,000 meters, there's no light at all. And so we have to bring our own light with us. It kind of annoys the fish at times, but at other times, it will draw them in. So we get to see a lot of really, really interesting fish and wildlife. In the 20 years or so that I've been doing this, the teams and I have found over 450 new species. And the guys that are going down there to Antarctica are probably going to find a few more, because not a lot of people have taken ROVs down to the deep ocean and down to Antarctica. Pardon me.
And students, if you also remember our video conference that we had last week, if you were there for that, you might remember Bettina showing us some pictures of some of the organisms that they have found at the bottom of the seabed so far, and some of those samples that she had mentioned they had been collecting using the ROV to bring up and do some DNA testing on. So this would be how they collected those samples.
Yeah, so that's a good point, Lizzie, thanks. So a lot of times they'll drag a net to try and collect samples. What that does is it picks up everything off the ocean floor. With an ROV, you can go down and you can pick things up off the ocean floor and just get the things that you want and leave everything else unharmed. So that's really cool. So if we could go to the next slide.
Yes.
Occasionally I go to sea with Bob Ballard. This is Dr. Robert Ballard, and he is with, he's over at the University of Rhode Island right now, but he has a ship called the Nautilus. And on board the Nautilus, he has, the next slide, we can show you his ROV, which is a really interesting, a very interesting setup. It has two ROVs. So you have Argus there, the silver one, and then the yellow one is Hercules. This is a two-part system, and we hover above Hercules with Argus, and we're able to watch the ROV actually do the work, which is kind of convenient because you can tell what's behind you, you can tell what's off to the side of you. And with this vehicle, we've actually been able to monitor a sperm whale swimming around the ROV in the Gulf of Mexico, which is really cool. Bob Ballard is a very interesting man. He's been doing this all his life. You might know him from his expedition finding the Titanic. He found the Titanic, and he said that, boy, he wished that he almost didn't do that because he wanted to be more well-known for being the person who actually found the hydrothermal vents in the Pacific Ocean and in the middle, off the mid-Atlantic coast, mid-Atlantic ridges. I can go into more of that if you have some questions about that later. But if we go to the next slide, I'll show you how these systems work. So in the deep ocean, you don't just look down at that ROV. We're looking down at it with Argus, and this is very convenient because we can pick up specimens using the cameras on the ROV, or we can use the cameras on the secondary ROV Argus. Go on to the next slide, please. There we go. Another thing that we do is we work with small ROVs. There's Sylvia Earle and a couple of other people that are good friends of ours that have worked with us. We've worked with Sylvia flying manned submarines. She works on the sanctuaries out and around the U.S. territories in the continental U.S. She has been a pioneer for women in science. So you young ladies that think that only men go out and do this kind of science, not true, not true at all. I'm finding that there are more women in science now than there ever were, and there may even be more women in science than men. So if you're interested in this kind of work, well, I strongly suggest you read up on Dr. Sylvia Earle. She's quite an explorer, and quite proud of her. The young lady next to her is Elizabeth, a friend of ours, who has been, Sylvia Earle was her hero for her entire life, and when she finally got to meet her, she was so terrified she didn't even talk to her. But she eventually warmed up to her and talked to her, and Sylvia was very, very nice to her. And since then, she's gone into science and marine science and teaching marine science. So I'm very proud of her. If we could go on to the next slide, I'll keep talking about this slide, but you can see the difference in sizes. So there are some ROVs that are as big as a small cart. This vehicle here is the one that they're using down in Antarctica. This is a Quasar. It's built by SMD, which is a company in England, and they build several research submarines every year. And fortunately, when I started, there were only about 8 or 10 research submarines or submersibles, ROVs. And now they're getting to be more and more. I think there's close to 20 at this point. But this vehicle is about the size of a big van, okay? It's about 11 feet long, 7 feet wide, and 8 feet high. And it's capable of diving to 4,000 meters or 2.5 miles down below the surface of the ocean. It goes down with that big orange cylinder on that you see on top, and it's just lowered down, and then another tether spools out from there, and the vehicle flies along. What's really cool is the ship. Okay, this ship is 300 plus feet long. Is that right, Lizzie?
I think so. It's
Just
very
over-
big.
I believe it's just over 300 feet long. But this ship is not in charge. The ROV is in charge. As the ROV goes down and it moves away from the ship, the pilots tell the ship's captain, please move to in this direction at this speed for half mile. And then the ship will slowly slide along and follow the ROV as it goes along the bottom of the ocean floor. That's called dynamic positioning. I could go into that, but that's, oh boy, that's a lot of time to talk. So if we could go on to the next slide, and pardon me. Here's one of the guys that flies the ROV. Here's one of the pilots. So usually they have between 4 and 6 pilots on any given expedition. I don't know if Ray is one of the chief pilots or if he's just one of your average everyday pilots that I joke about that, because an average everyday pilot is he probably has his master's degree in engineering, one field or another, and he's capable of pulling that whole ROV apart and putting it back together so that it works. I got to give this guy credit. He's down there in an extreme environment, and he's doing an extreme job, and he's doing it very well, I'm understanding. So to Ray and everybody else that's flying the ROV and the AUVs, kudos to you guys. And like I said, there's between 4 and 6 pilots at any given time. If you sit in the pilot's chair and fly for an hour in a dark room in a theater, I don't know about you guys, but if I get in a dark room watching a movie, I tend to fall asleep. And so they don't fall asleep. They rotate in and out every hour or two, and then they can fly this ROV 24 hours a day. So if we can go on to the next one. Thanks, Ray. And where is the ROV? We also should find out where the ship is. But what they do on the ROV, on the ship, is they have to have a garage for this ROV. So they have an enclosed room that they can slide the ROV to the very edge. You see the edge there with all the shivs. They would slide the ROV out, pick it up, and with that orange contraption that you saw in an earlier slide, they will pick it up, put it over the side, and spool it down to the very deep, dark ocean. The garage, fortunately for these guys, because they are in Antarctica, is heated. It can be closed. It's close to the waterline. So during the storms, when they're down there in the Antarctic, the seas just wash against the ship and don't come into the garage, where these guys have all sorts of instruments laid out that are on the, typically enclosed, but on the ROV. They have instruments and they have electronics and they have all sorts of things pulled apart. And these are things that you don't want to get salt water in. As they're pulling it apart and doing maintenance, which is what they're doing right now, they're safe, they're dry, and they're warm. So next slide, please. Yeah, this is the control room. And so when I first started flying ROVs, I sat down at the controls like this, and we had 34 monitors. I looked at my boss and I said, which monitor do I monitor? And he said, all of them. And I said, oh my gosh. So you see those two monitors with all of the diagrams and everything in them. That tells you what's going on with the ROV. So you can monitor whether or not you're getting salt water into a place where you don't want them, into the computer systems, you don't want water there, into the electronics, you don't want water there. So you can tell what's going on that submarine at any given time. Okay, the half round that you see up on the top row, that's the sonar. All right, sonar tells you what's out in front of you. So even if there's a lot of murky water down at the bottom, which there sometimes is, if a fish swims by and it swipes its tail across the bottom, it can bring up flock from the bottom of the ocean. And if the pilot, which I've never done, but I hear it has happened before, if the pilot lands the ROV in the sediment too hard, it comes up like a dust cloud all around you, and it'll block your view, your vision, and you have to use the sonar to see through all of that smudge is what we call it. But then you have the two other monitors. There's one with 4 screen, that one there. That gives you a look of, they can change the cameras at any given time so that they can monitor different things as they need to. And that one typically has the smaller cameras that either look down or look back. Sometimes they look up, so when they're bringing the ROV back up to the ship, they don't run it into the ship. And then they also see the winch, and they have to monitor all of that stuff. So it's a lot of work. So you have 2 guys. You have one that's flying the ROV, 2 pilots, and then you have your co-pilot that's typically monitoring everything that could possibly go wrong. And there's probably tens of thousands of things that could go wrong. But if you do it right, the system flies very well, and you can stay in the water indefinitely. So these guys are pretty neat guys. And if you or any of your friends are interested in learning how to fly these things, I recommend you do that because it's a great career. Yeah.
So Buzz, for this one, this is also a video from the Eclipse, which is the group that has provided the ROV. So we can watch just a quick I think it's just 2 minutes. So we'll take a quick 2 minute to see an ROV in action.
Right. So you have the fellow on the left with the joystick in his hand. That joystick pushes that vehicle back and forth, side to side, and allows it to crab. In his left hand, there's another switch that goes back and forth. Go ahead and roll the camera if you'd like.
Okay,
And,
I'm not sure if it's going to talk to us or not, but we'll see.
If it does, I'll not talk to you.
Okay. Oh.
There we go. Hydraulics. These are all run on hydraulics. The cameras are even, their pan and tilts are run on hydraulics. This is the underneath view. Sitting in the water is probably the most difficult thing to do because it's very vulnerable to ship strike. So they get it in the water and they push it down as fast as they can. And there's the umbilical. That's the tether that tethers it to the ship. And all of your video and instruments are linked through that through fibers and through copper cables. So here he is flying that system. 2 robotic arms. So the one on the right is called a rig master, and they just typically grab things and hold on to them while the other arm is doing all the work. This is the master arm that they use up on the ship in the control room. So when he moves that, he's able to make the other arm do the things that he's doing in the control room. It's kind of like a puppet. There you see a little bit of that flock that I was telling you about in the hazy water conditions. So it's always good to have a sonar. Helps you look through all that muck. See all those wires going into that big can? That's 4,000 volts of electricity going into a can. Can you imagine pumping 4,000 volts of electricity into the ocean, into the salt water? Man, oh man. That's not something that you want to mix every day.
Not at all.
Yeah.
All right, so I think now, Buzz, we could do some questions and answers. So I'm going to go ahead and stop sharing my screen so we can see you again.
Absolutely, yeah.
All right, so let's see. We have got, I believe we had, while we were sharing, we had a question from Ms. Hogturk's class first. And then students, if you have a question, you can raise your hand so I can see you in the screen. Excellent, so we'll go to Ms. Palmer's class after Ms. Hogturk. So I'm gonna go ahead and unmute you so you can ask your question, and then I'm gonna mute myself so we can have Buzz answer for us. All right, let's see. Oh, whoop, there we go. Ms. Hogturk, go right ahead.
Have ROVs been used for military purposes before?
Absolutely, yes. ROVs were primarily designed for the oil field. So working in the deep ocean as they were pumping oil out of the ocean, they would use, they developed these systems that would help them with that. But the military quickly learned that they were useful, and they have used them for a number of different purposes. If they drop something over the side and they need to go find it, if there's a shipwreck down there, the military likes to use them to go down and find out what's going on. They get the black boxes out of the ships and all that. So yes, they use them for a lot of diverse needs in the military. It's a good question. Yeah.
Excellent. So we'll go to Ms. Palmer's class next. So it looks like you have a couple of questions. So we'll start with, we can do two right now, and then we'll rotate around and you can ask another in a minute. So
okay, we have
right ahead.
Okay, thank you. We have two questions. One from Isaiah first.
What was the price of water?
How much they cost? And Savannah?
How close have you ever?
I'm sorry, I didn't. How much do they cost, and what was the other question?
How close have you come to finding the ship yet?
The Endurance.
I'm sorry. Can you get a little closer to the mic?
How close have you come to finding the ship yet?
Okay. So to answer the first question, how much do they cost? They can cost, well, the vehicles that I've flown in the past, anywhere from $4 million to $13 million. So they're not cheap, but you know, if you work hard enough and save your allowance, you can get one eventually. But as far as the Endurance is concerned, they are getting fairly close. So they knew where the ship was last seen. They have a very good idea about that. They know how the ice, so they're in the sea ice, and so the sea ice moves with the currents, and they kind of follow the currents that might have been during the wreck of the ship. And then, of course, it's made of wood, so did it float or did it sink immediately? It had a lot of metal in it, so there's a good chance that the ship may have gone, the big parts of the ship may have gone down fairly quickly. And so they have a pretty good idea of where that ship might be. They're going to put some AUVs in the water, and those AUVs are going to use multi-beam sonar to scan the bottom of the ocean to find a debris field, like they did with the Titanic. That's how they found it. They locate the debris field, and then they fly along and follow that debris field, and eventually they find the wreck. So I can't tell you exactly how close they are to finding this wreck, but I feel very confident that these guys will do it if anybody can.
And to add to that, we're so excited. We hope they do find it. We're also confident for them, but they're still in transit on their way to the site. So they just left the Larsen Sea ice shelf, and on Monday we got a little clip from Holly seeing the actual boat moving through the ice. So as we get our next question, I will look for that as well to see if I can show it to you at the end of the call. So I haven't gotten confirmation yet as to whether they've actually arrived at the location where they think the Endurance is, or whether they're still en route. So stay tuned for that as well. And yeah.
So to add to that, They are on an icebreaker, and if they're going through the open water, they can get there fairly quickly. But if the wind blows the ice in and they have to break through the ice, it could take them up to 2 weeks to get to the location that they're trying to get to. So it could take them a long time to get there. And breaking ice on a metal ship, can you imagine the noise? Wow.
Yeah, and then we had, if you remember, Sasha, our glaciologist who was with us a little last week, he also spoke to us about what it's like to be on board the ship as it breaks through the ice. So it looks like we have a question from Miss Long's class, and then it also, I saw in the chat that we have something coming through from Mr. Campbell's class as well. So we'll first do Miss Long and then head over to Mr. Campbell. So, Miss Long, go right ahead.
How big are the ROVs in weight and size?
How big are the ROVs in weight and size? The one that they're using for this expedition is an SMD quasar, and it's about 10,000 pounds, give or take, depending on what kind of instruments they put on it. It could go up to 12,000 pounds, and it could be as low as 9,000 pounds, but about 10,000 pounds. It's 8 feet high, it's 7 feet wide, and it's 11 feet long. Does that give you a good idea? Yes, sir. What question is yours? What do you have for a question?
Like, how does like the little hand thing that controls the AUV, like, how does it connect? Is like a line, or does it connect from like Wi-Fi?
Right. Great question. So how do you communicate to that robotic arm? You have to send signals down through a fiber cable down 2.5 miles or more. And the electronics in the arm itself will answer the request that you send down through the master arm. Does that make sense? Very cool.
All right, we're gonna head over to Mr. Campbell's class for a question, and then it looks like we've got one, also another one from Miss Palmer's class. And Mr. Thompson, I can't see your video, or Miss Patterson, but if you all have questions, type them into the chat and we could get you unmuted as well. So over to Mr. Campbell's next.
Waiting for a question?
Yes, we're waiting for a question.
When I did this stuff with scripts, we dropped 3 transponders in the area and used that to know exactly where you were in this field. You do something similar, or is it more advanced than that now?
It's we do use ultra short baseline tracking, but it's moved on a little bit. But that stuff is still very popular with the pilots, and it makes it possible to pinpoint points that you're looking at, points of interest that you're looking at. But for now, they use they're more often using the sonar on the vehicle and a tracking system on the vehicle. Once we get to a location, once we find a shipwreck, we'll put a transponder on that, and we only need to put one, and that's fairly fairly reliable. But like the ultra short baselines that you're talking about, if you have 3 targets to triangulate from, you're going to get a lot better a lot clearer information, and you'll be able to find the things that you're looking for much faster. Yeah.
Great. All right, Miss Palmer's class, we're headed on over to you all. Go right ahead.
What would happen if it broke?
Or got lost?
What would happen if it broke or got lost? So did you hear me talking about the transponders and the devices that we use to find things down there?
Sort of.
Sort of. So what happened is if we lose the vehicle, if the tether gets broken, at the ship, it'll typically drop down and anchor the ROV, so we can use another ROV to go down and collect that ROV. So what we do is we put an emergency beacon on it, and the emergency beacon we can use to ping the ROV that's down on the bottom of the ocean, and we can find it that way. So I have never lost one, and I've only heard of two vehicles out of thousands that have been in use. I've only heard of 2 being lost ever.
In the other session, Holly said that they had lost an ROV or an AUV. Is that?
That's right, yeah. So an AUV is programmed, it's untethered, and you put it in the water and you set it free, and it's supposed to do what you tell it in the program, in the computer program. It's supposed to follow a track that you send it on. On certain occasions, they lose their way, and they either auger into the bottom, where you can ping them with a tracker and find them as well. Or sometimes they'll come up under the ice and they'll get stuck up under the ice, and you have to find them with a tracking system as well and break through the ice, or put an ROV in the water to go down and pull it out from under the ice. I understand that's what happened. It got stuck up underneath the ice, and the ROV went in, put a hook on it, and pulled it back to the surface. So yeah, they do lose those occasionally. With an ROV, you can just pull on the tether and your system comes back to you. With an AUV, you have to be, you're sometimes going on an egg hunt.
And we have, I'm just going to share my screen really quickly with you all to show you exactly those pictures that Buzz is talking about of what it looks like when, well, let me share and I'll show you. So down here, you can see this is the AUV that you were just referring to, this big, it looks yellow here, it's on the computer screen, and this is the AUV that was lost, and then this right here is the orange hook, that is the hook coming from the ROV that went down to rescue the AUV. So you're exactly right, Ms. Palmer's class, they used both, the ROV went to save the AUV, and it hooks in right here, and then the next image is the AUV being brought up out of the ocean from the surface floor. This is the team here of the technicians who went down to gather it again, and that was how they recovered the AUV, was using the ROV, excuse me. And then also what is really quite cool, I'm not sure if all of you have been following or not, but Menson Bound, who is the chief explorer and marine archaeologist who's leading the team for the search in the Endurance, he has been writing his daily blog posts, and the last 2 posts he wrote about the recovery of the AUV using the ROV. So you can follow that if you go to our explore.reachtheworld.org website, which Chris will put into the chat for us, and you go to resources and click on daily log. You'll find Menson's blog posts there that tell the story of the recovery of that AUV. So it's quite exciting. There's 2 posts that are the posts about the recovery. So are there any other questions for Buzz about ROVs or his work down in the Antarctic? It looks like we have Ms. Hoggertop, and then we'll go over to Ms. Palmer has another, and then we'll see if Ms. Long or Mr. Campbell have any as well. So here we are. Ms. Hoggertop, go ahead.
Where do you learn to fly the ROVs, and how resilient are they, as in with crashing into rock or the ice?
Good questions. Where can you go to learn how to fly an ROV? There's one school that I know of in Canada. I run a small company and we teach students how to fly ROVs, scuba dive and do all that kind of thing. So we don't teach professionals to fly them. We teach people like you to fly them. If I can shamelessly put a plug in for OceansWide, we do that in Maine and here in New York. So if you're interested in learning how to fly one, that's a good place to start. But they are very resilient. They are able to, they have metal frames around them, of course. And so you can fly them into a rock or into a piece of ice as long as you don't damage the thrusters, don't break loose any of the foam or damage any of the other equipment on board. You can pretty much just bounce off things and go on your merry way. The good thing about an ROV is you probably heard that it's better to walk through the woods than run through the woods because you see more, right? ROVs are a slow-moving vehicle, and they move across the bottom of the ocean at about a half knot, usually, which is about a half mile an hour, which is about 4 times slower than you walk, okay? So we move along the bottom very slowly. And why do you think at 4,000 meters, a vehicle like that would move slowly across the ocean floor? You've got a tether that goes up to the ship, right?
Yeah.
It's almost an inch in diameter. And if you have 4 miles of, or 2.5 miles, I'm sorry, if you have 2.5 miles of tether out, you have the equivalent of 8 sheets of plywood. 4 by 8 sheets of plywood that you have to pull through the water. And so it makes it very difficult to go fast. But they're very powerful. They're able to carry that tether through the water. And but it does make them go slow. And going slow isn't a bad thing down there. Yeah. Great question. Great question.
Yeah, excellent. So now we have Miss Palmer, and then we'll go to Miss Long and back to Miss Hogturk. All right. So Miss Palmer, go ahead.
Oliver, go ahead.
Has anybody died in the expedition?
Oh gosh, no. No. I went down to the Antarctic for 34 cruises, or 70 cruises. I went down 34 times. And in the time that I was down there, nobody died. Okay. We're very safe because we're in a harsh environment. And so you don't go out on deck without somebody else. You don't go out on deck without something to float you. So you have a life jacket or a float coat on. You wear very warm clothes. When you're working on deck with all that machinery, all that equipment, you're very, very careful. And every one of the people that are down there are trained professionals that have been doing this for a long, long time. And you don't just send somebody out there that hasn't done it before. So if you went down to the Antarctic, I would take you with me and teach you what I know and slowly allow you to start doing the work that we do rather than just telling you to go out and do the work, okay? So
Yeah.
safety is number 1.
Absolutely. And to add to that, we had Holly just on Monday, they had a big drill on the boat. So you may have fire drills at school. They also had a fire drill where they had to simulate someone who was potentially, well, I'm not exactly sure what they did, but they had to simulate the entire drill as if it were real life. And then they did more than just a fire drill. So stay tuned. We'll see if Holly can write us an article about that. And then also way back to our very first video conference, we had our expedition leader, John Shears, who told us a little bit about some of the training that everyone who's on board had to go through before they got onto the ship. So they are, rest assured, they are very safe down there.
Yes.
So let's head over to Miss Long's class.
So when was the first OV used in that? made and how did you use it?
Oh my gosh, you're asking me a question that I don't know the answer to. When was the first ROV designed and built and used? Is that the question?
Yes.
Yes.
Okay. I'm going to say that in the 70s, they started building ROVs. And at first, what they were is a drop camera. So they'd put a camera on a cable and they'd lower it into the water. And then somebody said, well, what happens if we put propellers on it and we push it around with propellers? And then somebody said, well, we have to put some flotation on it. So over time, the ROV evolved. So just like today, you look at the cars out on the road, they're pretty advanced, right? 100 years ago, they were a Model T Ford. So just like cars, the ROVs started as a small, very simple instrument, and it has evolved over the years to be what it is today. Does that help?
Thank you.
Okay.
Excellent. So it looks like Ms. Hagerterps had one more question for us. So we'll unmute you. Go ahead.
I have two questions. One of them is, can it go up like and down like a submarine? Does it work that way? And then also, can you make the cord longer if you're down there whenever you want to?
Ah, that's a great question. So the ROV can go up and down like a submarine. Okay, it takes to go down 2.5 miles. It takes about 2 hours. All right, and it takes a little bit longer to come up because you're forcing it up through the water column. But it is able to go up and down. It's able to go side to side, crab, and it's basically able to do whatever a helicopter can do in the air, it can do in the water. Okay. And your second question, could you ask that again so everybody heard?
Can you make the cord longer when you're in the water whenever you want to?
Aha. So the tether is, they build the tether to be as long as the ROV is capable of diving. In the deep ocean, every 33 feet, you add 14.7 pounds per square inch, okay? So if you go down 33 feet, another 33 feet, every 33 feet you go down, you add about 15 pounds per square inch. So the instruments on the vehicle are only capable of withstanding so much pressure. And so we only put enough tether on to get down to the safe working depth that ROV is able to go to. So we don't have a need to extend the extension cord, right? So if we go any deeper than the safe working depth, the ROV starts to implode. All right, the water pressure is so strong that it will crush the cans that all of our electronics and equipment are in. So we don't want to go any deeper. But that's a great question.
Great, and it looks like we have a question over here from Miss Long's class. And then after that, we'll see if anyone has one last question for us before we say goodbye for the day. So Miss Long, go right ahead.
How long can the how many days can the ROVs on battery stay alive for?
Ah, another good question. Wow, you guys are good. So the ROV is powered from the generators on board the ship. So as long as the ship is running, as long as the generators are running, we can stay in the water. So there are no batteries on the ROVs. On most ROVs, there are no batteries that we have to worry about dying. On the AUVs, there are batteries. There are a lot of batteries on an AUV. And they typically have to come back every 8 hours to be charged. So the AUVs come back every 8 hours. The ROVs can stay in the water indefinitely. Usually we put them in the water until something breaks. All right? That could be 3-4 days.
Wow.
Wow is right. All right, does anybody have any final questions for Buzz today? I don't see any hands. Oh, Chris has something. Go ahead, Chris.
I just wanted to make sure that everyone saw a note that Mr. Campbell had shared with with everyone that, and I think this is in reference to the question about when did people first start using ROVs, and he said that he, at the tail end of Expedition Deep Toe in 1971 or 2, he was using things like sonar cameras and transponders. So for those of you who are trying to do the math, that means that for well over 40 years, people have been using this type of technology to be able to better explore the ocean.
Excellent, thank you. So students, if there are no other questions, I personally would love to thank Buzz Scott for joining us today. I feel like I personally have learned so much about ROVs today. I hope that you all have as well. And we will definitely keep you informed about the ocean, OceansWide, so you can learn how to be an ROV pilot. We have that link in the chat, and we can put it into the recorded video as well. And students, I'm going to go ahead and unmute you all as well, so you can say thank you to Buzz as well. So here we go.
Hi. Thank you, guys. It was great seeing you.
Thank you, Buzz.
Thank you.
Excellent. And we have another video conference tomorrow. Hopefully they will be finished with all of the maintenance on the ROVs, and we'll be able to hear from some members of the team who are going to be using those ROVs and looking for Sir Ernest Shackleton's ship, the Endurance. So stay tuned for tomorrow. And thank you so much, Buzz. Thank you to all the students and classes joining today, and we will see you again soon.
Thank you. I hope they get that ROV back in the water as soon as they can, and I look forward to seeing what they find.
Absolutely, yeah. Us too. All right, thank you everyone, and have a wonderful afternoon.
Bye-bye.
Bye.